This is the introduction to section 7.3. This is part 2 of your notes. And in part 2, we're going to be looking at proving triangles similar still. And this time we're going to be looking at proofs, a couple of proofs here that we're going to look at. Okay, now these proofs are slightly different as we look at them. I mean, you're going to see some of the same things as we go through, but they are going to also have some different things in them as well. So, as you look at your first proof, we have our given information here, and the given information is marked in our two triangles, and we want to prove that triangle FGH is similar to triangle JKL. Okay, so in order to do that, we have to show that using one of three things: the angle-angle similarity, side-angle-side similarity, or the side-side-side similarity. Okay, so as we're going through on this, we have to either show that two sides with a corresponding or with a included angle, and we also have to show that three sides, or we can show that two angles. And if you remember, the one to show that is probably the easiest is to show that two angles are congruent in each triangle. Okay, if you can show that, then you can show that the triangles are similar. So as you look here at this, at the proof, you look at FG is congruent to GH, and JK is congruent to KL, and then it says angle F and angle J are congruent to each other. Okay, so what I'm going to do now is we look at this proof. You'll notice as you look at the big triangle here that you have an isosceles triangle. So if you have an isosceles triangle, again, as you're looking at these two, in order to show it with side angle side, I have to show angle G is congruent to angle K. Well, there's no way to show that in this problem. Or if I do side angle side similarity, I have to show that FH is congruent to JL, which again, in this problem, there's no way to show that. So I have eliminated essentially these two, side angle side and side side side. So I'm going to try and show that two corresponding angles in each triangle are congruent with the angle-angle similarity. Okay, so as you look at the first triangle, the top one up here, you notice this is an isosceles triangle. So if it's an isosceles triangle, you know that if the sides are congruent, well, then the base angles are congruent. So I can say in step one that angle F is congruent to angle H. And this is by the isosceles triangle theorem. Okay. Now, if I know that angle F is congruent to angle H, I put my mark in here, then I also know that as I'm looking at these here, that angle H is congruent to angle J, because you'll notice they have the same markings here now. So if F is congruent to J and F is congruent to H, then I know that angle H is congruent to angle J, and this goes back a little ways by the transitive property. Okay, so now I'm going to put a big letter A next to this. There's one set of angles. Angle H is congruent to angle J. That's one pair that I need to have congruent. I need to have another pair congruent. Now, if you look at the second triangle, if you look at the small triangle, it is also an isosceles triangle, which means if the base side or if the sides are congruent, that the base angles are congruent. So now I can say that angle J is congruent to angle L by the isosceles triangle theorem again. So I know that that guy's going to be congruent to each other. Well, if J is congruent to L, here J is congruent to L, and then F is congruent to J. If they're both congruent to J, then they're both congruent to each other. So now angle F is congruent to angle L. Angle F is congruent to angle L, and this is also by the transitive property. And if you'll notice here, again, F and L, here's angle F, it corresponds with angle L. So this is my second angle that I'm looking for. And now I can show that triangle FGH is similar to triangle JKL by the angle similarity. Okay, so that kind of goes with two things. We've talked about the isosceles triangle theorem here recently quite a bit, and it also looks back in the transitive property as well. Okay, the second one is not near as challenging. Okay, so as we look here, MP is parallel to AC, and again, we need to show that the two triangles are similar. Now, again, the easiest way to do this is to show two angles, if we can. You know you have one set of angles here, automatically. You know, to start, you know that these guys are going to be equal to each other because they're verticals. So all I would have to do is show one more pair of angles. So I'm going to go ahead and mark that down. I've got angle CBA is congruent to angle MBP, and that's because vertical angles are congruent. Okay, so there's one angle in my match. And then I also says in the given that MP is parallel to AC. So I could say one of two things here. I could say angle C is congruent to angle M. Or I could say angle P is congruent to angle A. Either one, it doesn't really matter. I'm going to use C and M. Angle C is congruent to angle M. And they're congruent because they're alternate interior angles are congruent. So now I've shown that these two have two angles that are corresponding with each other, congruent to each other. So now I can show that triangle ABC is similar to triangle PBM by the angle similarity. Okay, so this gives you two options to look at in terms of a proof as examples of things to look for. Okay, this concludes section 7.3 part 2. Don't forget to complete your WSQ.